Okay, the the main focus is now on decarbonizing and swift transformation of shipping. So this is what is now leading to lot of market-driven changes. IMO has its own short-term targets, while RightShip has a dynamic GHG rating methodology that will require vessels to continue improving the performance throughout the life. Next, what is would be coming is the EU Fit for 55 that will be coming in force in 2030, and essentially the EU ETS would become a carbon tax regime that gives the possibility of a faster transformation towards a low carbon and carbon neutral fuel power. As short-term performance improvement, this can be done through combination of existing technologies, while the midterm improvements probably would be through combination of new and existing technologies. These would all be aimed at reducing NOx, SOx, and improving the EDI values. But for the long-term goals, it has to be a shift away from the fossil fuel that is unavoidable. There's a lot of research and development going on for zero-emission designs. Anglo-Eastern has been working on that. We have developed a particular design for a bulk carrier. And initially we started off with hydrogen, but then obviously that was limited to tugboats and smaller vessels. So if you look at the design, operation, and propulsion, how things are being done and changing. Initially, if you see the optimization of hull and flow profile to reduce skin resistance and improving weight power ratio has gone through a fantastic transformation over the years. Equipment efficiency is another area where a lot of work has been done. And then there are other technologies that are being used to reduce overall fuel consumption, essentially to reduce emission from ships. As Dr. Suhash mentioned, operational efficiency is important. That also leads and contributes to the reduction of fuel consumption and thus improving emission, and that is directly related to CII. EEXI and CII are areas of attention at this time for short-term goals, especially for the older tonnage. Apart from limiting maximum power, there are various other modifications that are possible and that can be adapted to improve vessel performance. All the improvements or modifications that has been done is essentially aimed more for reducing the actual fuel consumption and improving the CII. Now, coming to propulsion technologies, the tier 3 design is already in the market. LNG fuel, LPG, methanol fuel are being used already, but they are not carbon neutral, and there is greenhouse gas emission. Biofuel is also drawing a lot of attention, but there is, again, as Dr. Suhash mentioned, there is a sustainability issue. It conflicts with the food cycle. As Anglo-Eastern, we are running a few vessels on biofuel, LNG, and LPG. However, and also we have got a couple of projects of smaller tugboats and offshore vessels which are on under construction at present with hydrogen. The discussion on ammonia is as fuel is now picking up. One problem with biofuel is that, matter of fact, there is not much data available as far as emissions are concerned. Biofuel is being tested by MN at this time to measure and analyze the emissions. For short-term goals, apart from the EPL, that is the limiting the engine power, there are other means, the category A technologies that will reduce the overall power, and it become an integral part of the vessel performance. The category B technologies that also reduces the propulsion power, but they'll be separately calculated with the, not included in the EEDI formula directly. And then there are the category C technologies that generate electricity, but some of them may be dependent on ambient conditions as well. For all the options selected, there would be requirement for CFD analysis, and in some cases, a sea trial would be required after the modifications. Everything is aimed at reducing the CII, and this includes vessel performance and vessel voyage routing, because these operational items are important. There are various measures possible to reduce the EEDI, EXI, and CII. These are when we are proposing to our clients, we make a calculation. An efficient and responsible operation measure will also help in reducing the CII. There's an example of one of the vessels of the 650 vessels under our management. We are carrying out our analysis, and we are doing the analysis for the EXI and CI values. Our environmental department is dedicated to in doing this work, and here is a case where 32% reduction in engine power was required. However, when we give a recommendation to our partnership owners, we give various combinations as to what can, including the category A, B, C options, how, so that the engine power limitation can be reduced. It's another example where we have a almost 21% reduction requirement. We make a calculation as to how much engine power limitation would be required, and then we give our recommendation based on category A or B and C. So in total, what happens is that we give, when we propose, we give a recommendation to our clients based on optimum combination of system and cost, and again, it is from the available retrofit options that we take our now coming to alternative fuel. For midterm and long-term goals, sustainability of alternative fuel needs to be investigated, as mentioned also by Dr. Subhash. With the information available as of now, ammonia looks to be the fuel of the future, and the ammonia engine would be ready by end of 24. That is what we understand. However, methanol needs a special mention because of the fact that large number of vessels are being ordered on methanol now. If you look at methanol, then there is just about 11% reduction in carbon emission and just for 5% improvement in EEDI. So this, until and unless I mean, the conventional production of methanol may not be the best alternative fuel. So we concentrated on ammonia, and ammonia is not a cryogenic fuel, and ammonia, of course, there's a question of toxicity which can be handled. We developed a design for a 210,000 deadweight Newcastle Max with ammonia as fuel, we use type A fuel tanks. There is a zero cargo loss, of course, and we got an approval in principle from Lloyd's. Most of the design work that is actually pending is because LR do not have or has still not established criteria for certain things. So we have to wait for LR establishing the criteria. And then there are some items that we require more information on from the engine maker, MN. During this process, we have worked with MN also. We developed a fuel supply system, which we have discussed with MN, and of course, MN now have a fuel supply system design. At the same time, we are also working with on a retrofit design for Newcastle Max. Here we are using a Type C tank. Our design work actually is over, and we are now completing the report, and we will be submitting it for class approval end of next month. The design again ensures that there is zero cargo volume loss, and we are already discussing with two shipyards for the retrofit. For the new building, we already have ammonia ready vessels on order for the vessels being delivered till 24, and the 25 onwards would be with ammonia as a dual fuel installed. Now, if you ammonia again is it if it's produced by the conventional method, is it sustainable? It's a very energy intensive process in producing ammonia, as in any other alternative fuel. If you look at the process, there is a huge amount of carbon dioxide emission, and there is a large amount of energy input required. There's almost 8 to 12 megawatt hour per ton of ammonia produced, and only half of it is available for use, and it produces almost 4 tons of CO2 per metric ton of ammonia. So overall, the whole system is energy intensive and in a way not sustainable. So how do we produce ammonia or any other alternative fuel in a net and have a net zero well to wake cycle? We know we can use renewable energy, wind or solar. However, there is a risk of producing waste. Already in the North Sea windmill farms, there are the first generation windmills are being decommissioned, and solar panels, there may be a difficulty in handling them because it's difficult to recycle. So that brings us to nuclear power. Can nuclear power be used? Because we cannot use nuclear. Definitely, nuclear energy is not going to be used as vessel propulsion in the foreseeable future because of the perception, the cost, the training, all involved. So, can we use nuclear power as means to produce ammonia or any other alternative fuel? Matter of fact, thorium molten salt reactor is already available. This technology is available. There is this can be an option. Thorium is not weapon grade, so the issues of falling in wrong hands does not arise. Anglo-Eastern is working with a company called Core, and we are working towards this concept of using a molten salt reactor as a means to produce alternative fuel. This is Kumar. this is all I have to say. If any questions are there, I'd be happy to take.
Thank you so much. We are getting questions in. That was a very interesting statement you made about the test vessel that you did, where you had to do a 32% reduction in the engine power. So does this then mean that there has to be derating of the engines, retrofitting of equipment?
No, it is no. You're just limiting the engine power, the maximum power. But this is overrideable. You can override it in an emergency. But what we did was we didn't have to do 21% reduction in engine power. We did just, I think, if I remember correctly, 14%, and the rest we were able to compensate with modifications and other means, category A, B, and C. So.
Right.
And that way we didn't have to reduce the vessel speed, because reducing vessel speed many a times would drive a ship out of trade altogether.
Correct. So do you reckon that in order to comply with this in the future, new buildings would come in optimized to this, or will they still do the reduction?
No, the new buildings are already EDA phase 3. So
Right.
this design is already there, and so it's not a problem as far as new building is concerned. But it is mostly the concern for older tonnage.
Okay. Fine. I have a question from Mr. Anil Tyagi. He says, why is hydrogen fuel limited to certain types of vessels? What are design or operational issues anticipated to be faced for the same?
Yeah, okay. Hydrogen, we did initially start with hydrogen because we have one of our partnership owners who in Belgium who also own a engine called ABC,
right?
Marine engine called ABC, and they have a hydrogen dual fuel engine over there. So we initially started off with a hydrogen as a fuel concept, but then obviously it is not a viable solution, not only because of the cost and in storage, but also the volume of hydrogen that would be required. Then there is also availability problems. So hydrogen may not be, at least at this time, hydrogen would not be available wholly, and so it is limited to smaller vessels where you can easily use hydrogen. What we are doing for our new building, it is basically hydrogen cylinders would be replaced every time the boat comes to shore. We are also actually operating hydroville in Belgium,
yes.
Which is right.
Yeah, correct. So this would be limited then to smaller craft.
Smaller tonnage, yes.
Yes.
Mostly offshore and tugboats.
Okay.
At least for this at this time.
There's another question asking on the feasibility of using wind energy, which can be part of the ship itself.
Yes, of course. Wind energy. We also have projects where we are using Flettner rotors. Yes, but then that is only coming in. If you look at the IMO, description, it is coming in as a category C. So it is generating just the power generated is not enough to reduce the fuel consumption substantially.
Okay. On the same note, I have also read about forays into trying solar panels to contribute to the vessel's power grid and thereby reduce the auxiliary fuel consumption on board.
Yes. Yes, we did investigate on the solar panel, but no, it was not a very attractive solution. So of course there are some mm, I think ABS has come up with a LNG vessel concept with solar panel and rotors similar to Flettner and dual fuel, but that solar panel did not turn out to be a very attractive solution for the vessels that we are considering.
Okay. So in your research, do you envisage maybe a hybrid solution where you have a combination of
We have
some of
hybrids.
these?
Yes, we have actually got one project ongoing
Mm.
where we have got hydrogen as fuel, a small vessel again, SOV for the wind farms. Hydrogen as fuel with battery
Right.
as backup. So that is of course again hybrid solutions for smaller vessels. Yes, for larger vessels, as of now, probably not a very attractive solution. But we also have some of our ships where we are using. I mean, about to install fuel cells
Mhm.
to supplement the mm, the auxiliary engine, the total load.
Okay, that's good. You had mentioned about zero cargo volume loss
Correct.
for the ammonia vessels. Is that
Correct.
Does that mean that the vessel's operational range will remain
Yes.
just the same?
Yeah. So we have picked up. I mean, this target vessels.
Yeah,
It is on a dedicated trade route between Australia and China.
right.
So at this time, we have information regarding Singapore being a possible bunker point,
Mhm.
which they're talking about developing. At the same time, we also there is a possibility of uh, points being developed, or facilities being developed in Australia. So
Okay.
our design is with fuel for one round trip
Mm.
and bunkering at Singapore.
Okay.
So that's how we have calculated.
Oh, okay. Thanks. There was another question on for short sea passage vessels or for larger vessels that spend longer times in port. Would shore power usage be a good alternative in your opinion?
Yes, yes, we for all our almost all our new buildings, we are putting shore power and AM or AMP, and that is also very useful even for reducing the CII, because when you're in port, you reduce the fuel because CII is essentially the actual physical fuel consumption. So when you're in port, you can if you're connected to shore power, you can reduce the fuel consumption for the vessel itself. So yes, and there are for especially for container ships, even the older tonnage, I think almost all container ships are being retrofitted with AMP if it is already not there.
Mhm.
So
And will this be available uh, at key ports and terminals, for vessels that
yes, I mean they lot of ports already have, especially in the US. China also have been developing facilities. So this will come up, and obviously depending upon the trade of the vessel, if it's a fixed trade and vessels are going to ports where the facility is provided, then obviously it's a good idea to have it, and that is what we are doing as well.
okay, that's great. There's a question from Mr. Jyotisman Dasgupta, and it says, has Anglo-Eastern considered carbon capture for high power liner ships?
No, we have not. We have not considered carbon capture. No, we have not.
Okay.
And we are actually also, we have not done any study on that.
Okay.